Hi, in this video we're going to look at how to solve the kinematic equations. I'm going to do problems 1 and 2 from the Kinematics 1 worksheet. Feel free to go to that worksheet and try problems 1 and 2 before you watch the rest of this video. Okay, so we are going to start to solve kinematic 1, the first problem on the kinematic 1 worksheet. This particular problem says a car is traveling 26 meters per second. That's an initial velocity of 26 meters per second. The driver steps on the brakes and the car comes to a stop. A stop means that the final velocity is 0 meters per second. And this whole thing happens in a displacement of 60 meters. What is the acceleration? And one of the questions I'm going to ask is, how long does it take? So we have 3 pieces of data: initial velocity, final velocity, and displacement. If you have those 3 pieces of data, you can solve for a 4th piece of data. If you don't have initial velocity or acceleration, which we don't have acceleration here, we must solve for that before we solve for anything else. You must have initial velocity and acceleration, or you must be able to find initial velocity and acceleration first before you can solve for anything else. Looking at this equation, I think back to my kinematics, and I think immediately of the 3rd kinematic equation. V final squared is equal to V initial squared plus 2 times the acceleration times the displacement. And we have the final velocity, which is 0. We have the initial velocity, which is 26. We square that, plus 2 times A times X, which is 60. So when we put this together, we get 0 is equal to 676 plus 120A. So A is equal to 676 divided by 120, which gives us a value of 5.6 meters per second squared. Once you know the acceleration, solving for the initial velocity, or solving for the time, is much easier. So to solve for time in this problem, we would say that the final velocity is equal to the initial velocity plus AT. This is our first kinematic. Once we know that we are dealing with the first kinematic, we see that we know the final velocity of 0. We know the initial velocity of 26. We now have the acceleration, which is going to be negative. When I brought this over to the other side, that did become negative, so it should have been negative 5.6. And we would have that here, negative 5.6 t. So t is equal to negative 26. When you brought 26 to the other side, it becomes negative, divided by, again, negative 5.6. And so when we plug that into our calculators, we get the value of 4.6 seconds. So t is 4.6 seconds. So we've used the first kinematic, and we have used the 3rd kinematic to solve this problem. In our second problem, it says an airplane travels 1,000 feet at a constant acceleration while taking off. It starts from rest. So our displacement is 1,000 feet. Our initial velocity is 0 feet per second. And it takes 25 seconds to take off here. So the 25 seconds, if we know the data on the screen, position, initial velocity, and time, that means we don't know the final velocity. And again, we don't know the acceleration. We must find the acceleration before we find the final velocity. You must have that first. And so looking at this, I can see the second kinematic equation. X is equal to V initial t plus 1/2 AT squared. When I plug in my numbers, I have 1,000 is equal to 0. We love 0. 0 makes any term go away. 0 times anything is 0. So equals 0 plus 1/2 A times the time of 25 squared. So we get the value of 1,000 is equal to 312.5 A. So A in this particular case ends up to be 3.2 meters per second squared. Now, we also need to solve here for the final velocity. And once I have 4 pieces of data, the first kinematic becomes very easy. The final velocity is equal to the initial velocity plus AT. We know the initial velocity is 0, so this term is gone. So we get, it should be AT, no square, AT, I said it correct. So the final velocity is equal to the acceleration of 3.2 times the time of 25 seconds. And so the final velocity in this case is 3.2 times 25, 80 feet per second. It's very important that you always have units. I always recommend circling your answer. And if you have any questions, don't hesitate to ask. Have a great day.